Okay, you can check this diagram also. This diagram and this diagram is exactly same. Okay. So here we are taking two lines. We are taking one line in space. So I want to find what will be the moment of inertia about what will be the moment of inertia of this triangle about the line lambda. Then I take one line parallel to lambda, which is passing through A. Okay, so this I'm taking as lambda dash, and the moment of inertia about this is denoted as I lambda dash. At this point, in this line, the moment of inertia is denoted by I lambda. I want to find what will be the moment of inertia about this line. And the moment of inertia passing to the centroid is taken as Ig. Okay, so this distance is taken as Ig. Now here, from each vertex, the distance are given. So the distance from the first vertex, we are taking h1, and this distance I'm taking h2, and this distance I'm taking as h3. So if we compare this from the diagram, we can easily see that h1 is smaller than h2, and h2 is smaller than h3. So we are taking this. So here we have, see, we are trying to find the moment of inertia about any line lambda in space by using the above result. We are going to use this result afterwards. So this is what we are taking this triangle. Okay, this is triangle D dash. So we have this triangle here. We have taken D and this. So I have explained already about the diagram. So these are the distance, and where the distance is h1 is less than h2 is less than 3 h3, and m is the mass of the triangle ABC. Now let us find the distance of C and B from lambda dash. Let us find the distance of C and B from lambda dash. Okay, distance of C and B from lambda dash. If we can see here, we are trying to find the distance of C and B from lambda dash. So what will be the distance of C from lambda dash? What will be your distance? Okay, so here you have taken, first we have taken here C and B. Yeah, C. So let us find what will be the distance of this from lambda dash. Check the diagram properly. So we can see that this distance is h1. So we want to find this distance till lambda dash. So this whole distance is h3. So it will be nothing but h3 minus h1. So we get the distance of C from lambda dash is h3 minus h1. Okay, and in the same way we'll try to find the distance of B from lambda dash. So this is the distance. So I can take the whole distance minus this distance, I get this distance. So that is the distance of B from lambda dash. Okay, so that is h2 minus h1. So we have already find the distance of C and B from lambda dash. Now I'm taking the mass. Okay, I'm taking the mass of this triangle ACD. Okay, triangle ACD. If you are confused with the diagram, you can check this diagram. So ACD I'm taking as M1, the mass of that, and the mass of this ABD I'm taking as M2. So the total mass, the mass of this triangle is M. So okay, so the mass of this triangle is M. That is nothing but mass of this triangle, mass of triangle ACD minus mass of the triangle ABD. So here we have mass of the triangle ABC is equal to mass of the triangle ACD minus mass of the triangle ABD or BAD. So here we'll take this. Now we have here this one. This is M1, M2. Okay, so we'll try to find the mass. So mass is area into density. Okay, area into density. So what is the area of the triangle? Area of this triangle A, we are taking this area of this triangle ACD. Okay, ACD. So we are taking the base as AD. Okay, we are taking the base as AD, and the height, what is the height of this triangle? Height of this triangle we are taking as that is the distance. Okay, so this is your, if you look this triangle, the base here, I'm taking the triangle ACD. So the base of this triangle is AD, and the height is nothing but this. Okay, this is the height of the triangle. So what is this distance? It is h3 minus h1. So here the mass is density into half AD, h3 minus h1. Okay, in the same way for this triangle ABD. So the height base is AD, height is this, so that is nothing but H2 minus H1. So we get here density half into AD, H2 minus H1. So this and this get cancelled. We are getting here H3 minus H1 divided by H2 minus H1. So here we have what? This is M1, M2 equal to H3 minus H1 divided by H2 minus H1. So bring this one to this side and this one to this side. Now you minus this two, okay? So this minus this. So if you minus M1 minus M2, what is this? This is M. And here also if you minus this one. So if you minus here, this become minus, this become plus. So this and this get cancelled. We get H3 minus H2. So we get M by H3 minus H2. Now you equate this with this and we get M1. You equate this with this, we get M2. So we have got M1 and M2. So I have explained in the beginning already that I lambda is the moment of inertia about the moment of inertia of triangle ABC about the line lambda, and I lambda dash is the moment of inertia of triangle ABC about the line lambda dash. Okay, and Ig is the moment of inertia about the line lambda for the triangle ABC. And all these lines are parallel, so we can use the parallel axis theorems also. You can use the parallel axis theorem. So this I'll explain in the next video. Thank you.